actually, shall we call this as a charging phase? There's a discharging phase. There's a discharging, and this particular thing is what? Charging. During charging, discharging, how the circuit will be? And is asking the time period. So charging, discharging. So we'll write this as charging and discharging as T1 and T2 separately. Now, there's a very popular instrument which will generate a waveform of like this. Okay, what is our question? So this is the T2, you write it. And there's a charging called T1. Okay, there's a charging phase, discharging phase. And now, what are the conditions? Closes when Vc equal to 2V/3. So during discharging, so from where it will discharge from 2V/3, no? Don't bother this particular thing. No? So try to analyze the circuit from here. So it is discharging at discharges. So from initial what voltage? 2V/3. So like during discharging. See, everyone knows RC circuit. So no, the application is what you have to learn here now slowly. During discharging, what was the initial voltage? 2V/3. Go back to the RC discharging. So what is the voltage? V equal to V naught e to power of minus t lambda. V naught is what? Voltage is like at steady state or that particular from where it starts discharging. This is a discharging phenomena. So what are the initial voltage when it starts discharging? 2V/3 e to power of minus T2 by time constant during discharging. So what is the time taken? What is T2? Time taken for the voltage from 2V/3 to become V/3. What is lambda 2? We have to determine. Okay, look at the circuit condition. So what can be lambda 2? Not visible. That is. Okay, read it. What is the time constant during discharging? R2, C2 only, because the switch will be closed. You try to read. Okay, I'll give the circuit diagram. The capacitor circuit will be only this much. When the switch is closed, shorted, no? So there's the condition that will arise. What is the time constant of circuit? Lambda 2 should be equal to R2C. And what is R2? 3R. Okay, this will become 1/2 equal to e to power of minus T2 3RC. So therefore, this will be 2 equal to e to power of T2 3RC. Log 2. There's a discharging. Okay, during charging, we'll get into this one. During charging, the switch will be open. So when the switch is open, just you have to, I think, only you have to read the question, nothing big. If the switch is open, so what is the charging? What is the time constant of circuit? Will be R1 plus R2 into C. So time constant of circuit will be R1 plus R2 into C. This will be, I think, R1 is 6R plus 3R into C. 9RC is what lambda 1. Now, what is the expression for voltage across capacitor during charging? During charging, what shall we'll write here? This is what the charging one. This is a charging graph. If you permit it, it will get charged up to V. I didn't show it. One curve, I'll show it. If you permit it, no, it will charge up to V, but we are not permitting it. So this should be the V. Time taken for the voltage to become 2V/3. So V into 1 minus T 9 RC. Solve this, you'll get T1. Anybody T1? Anybody value T1 in terms of RC log? All of you can hear me?
Yes, sir.
Okay, anybody just calculate the value of T1.
Nine RC and
9 RC log 2. Okay, total time will be T1 plus T2. So this will be 12 RC log 2. So log 2 value, substitute and work out here. No need to fight with anything here. Can be expected some application problems. So you need not to bother that, say, like, what is the